right, let's start looking at what this dimensioning standard says. Here's good old ASME Y14.5. This second slide here has bullet points that just summarize what it is we're going to talk about in this PowerPoint. It's got quite a few slides. So here are the main points. And by the way, in your quiz for this time, I think the quiz has questions for the first 1, 2, 3, 4 points here. When we make dimensions, we put them on the dimension layer where the lines are thin, so that they look different from the object lines, which are thick. Let's look at extension lines, and whatever they are, it's okay to cross them. So what are they? Extension lines are thin lines that are extensions of the surface. You extend the part with these thin lines so that you can put dimensions on them. And when you're dimensioning a part, in AutoCAD, when you get the dimension command, you snap with OSnap to the corners you want to dimension, and AutoCAD will automatically put in a gap between that corner and where the extension line starts. It does that for you. If you snap someplace else, like let's say you snap down at the bottom, you won't be able to see that gap and it'll look not good. So we always want to snap to those corners. Extension lines can cross. And in fact, in most drawings, extension lines have to cross because there's just no other way. So for example, here's a part. It's got some extension lines that go horizontally. It's got some extension lines that go vertically, and notice they cross totally fine. Also, extension lines can go across the surface of the part like this one does, no problem. And down at the bottom of the slide I have put some text from the source document from ASME Y14.5 so that you can see what it actually says. A couple of fancy things you can do with extension lines. It does allow you to make breaks in extension lines if you think you need to. I have never broken an extension line in my life, and I've been dimensioning for many decades, and I haven't found a need yet. But who knows? Maybe your boss will say, oh, you should break it around the arrowheads, and if so, ASME says that's okay. Another thing you can do with extension lines is on a part that has a rounded corner, you can use extension lines to show where that corner would be if it were not rounded off. And a lot of people making parts like to know that sort of thing. All right, now let's look at the other kind of line, the dimension lines, where crossing is not okay. Dimension lines are the ones with the arrows on them. So there's text, there's an arrow, that's a dimension line. Not okay to cross them. So for example, this part up at the top has dimension lines that are crossed by other lines, extension lines running through dimension lines. Not good. Down here at the bottom, this dimension line is crossing over some extension lines, and believe it or not, this one up at the top is also crossing, for the reason that the 0.38 dimension has the arrows flipped outside, but if you ran the dimension line all the way through without flipping them, you'd see, oh yeah, that does cross also. The way to avoid crossing dimensions is always to do it this way. Put the shortest dimension close to the part, put the biggest dimension away from the part. If you do that, you will not have crossing dimension lines and all will be well. So here's this thing that we looked at earlier. If they had put the small 0.19 dimension close to the part and the big 0.38 dimension away from the part, then there would be no crossing. And here is ASME telling us precisely that, to minimize crossing, put the small dimension close to the part. Now there are guidelines about how far apart the dimensions must be to avoid cramped, messy looking drawings. And here's what ASME says. The first dimension must be at least 0.4 away from the part when printed. Now, if you're scaling your part half size, quarter size or something, then you have to scale this distance so that when it's printed on the piece of paper, you wind up with at least 0.4 away from the object. Then subsequent dimensions, from the second dimension to the third dimension, must be at least 0.24 inches apart when printed. These numbers might seem odd, and that's because ASME gives these spacing dimensions in millimeters. The ASME standard is metric, so if you translate 10 millimeters to inches, you get about 0.4 inch. Well, as a drafter working in a drawing with inches, you would be allowed to say, well, okay, 0.4, that's approximately 3/8 of an inch. I'm going for 3/8. And then 0.24 apart for subsequent dimensions, that's approximately 1/4 of an inch. I'm going for 1/4. That's totally fine. They must be at least that far away and at least that far apart. They can be more, they just can't be closer. And then whatever spacing you decide on, to make your drawing look professional, make all the dimensions uniformly spaced. So if you're going to make them 1/4 inch apart, make all of them 1/4 inch apart. If you're going to make them 1/2 inch apart, then make all of them 1/2 inch apart. Now, when you're thinking about that first dimension, about 3/8 of an inch away from the part, it's not just from the literal surface up, like we see in this part that has a bump sticking up. The dimension has to be 3/8 of an inch above the bump as well, even though what we're dimensioning is this land, this flat surface to the left. Our dimension needs to be 0.4 above the part itself, where that bump is sticking up. Sometimes you have to use your judgment. This tip to align your dimensions wherever possible is probably the #1 attribute of a professional looking drawing. When you are locating your dimensions, you'll put one dimension down, then use an O-snap to locate the next dimension so that it snaps right to the first dimension's endpoint. Get them all lined up. Your reader will think, this is a good looking drawing, and they won't know why it's a good looking drawing. It's just that it will be. Then try to put dimensions in between views if possible. It's not always possible, but where you can, try to do that. And the reason for that is you're trying to make life easier for your internal customer who's using your drawing. And if you have this width dimension in between the front and the top view, for example, it's easier for the reader to understand how those views are related and that they both have that same width. If you put the dimension outside the views, it just takes an extra fraction of a second to try and figure out what's happening. Do not have an extension line connecting those two views. This dimension just belongs to one view. This dimension just belongs to one view. So you don't connect them with extension lines. You just try to show the dimensions in between views wherever it's possible. And you keep the dimensions off the part, again, wherever possible. In this particular part right here, it is possible. So the example at the bottom is not good. That 0.18 is on the part when it could be pulled outside. And that 1/2 inch is basically on the part down here inside the L when it could be pulled up above the part. Now sometimes you're doing a part that has just all kinds of details in the midst of the thing, and there's no way to dimension it cleanly without having some dimensions on the part. Then it's okay to put dimensions on the part. But if you can possibly avoid it, avoid it. Other examples. Good, bad. Oh, this is just ASME telling us what to do if you have a little tiny dimension. I've never done these slanty extension lines. I think there's a special option in the dimensioning command for that. I've never used it. I have done these dog legs. You can do those. I like those, although it doesn't come up very often. Then, when you're dimensioning a whole stack of dimensions, like in this block in the lower right of the drawing, see how in the height dimensions these numbers appear to run together, and then in the width dimensions these numbers are, well, they don't run together, but they're kind of hard to read because they're so close. What ASME says to do is to move those pieces of text so that they are staggered a little bit, as you see in the upper right corner. And you can do that just by clicking on a dimension. A grip will light up, and then click on the grip again, so it's a hot grip, and just drag the text to wherever you want it. This page is out of our book. It summarizes all these various rules about dimensioning. I don't know if you like it. I put it in here in case you do like it. I don't like it. It's just hard for me to read. And I think I finally figured out why I think it's hard. Because if you're trying to figure out some guideline here, like let's say this distance m, you can't just look at the picture and see how far is that. You have to go, okay, m, where is m? Oh, m, that's down there. All right, here, blah, blah, blah. So your eye has to do a bunch of bouncing back and forth. That's related to another graphic design guideline, actually. When you're doing things like maps, they tell you, try to avoid legends if you can. Try to label the feature right on the map if you can. So here's an example of why that's good. And then a final guideline, which we will talk about in more detail in another lecture. Always dimension a feature in the view where it appears true size and shape. Here is an L-shaped bracket that has one rounded end with a hole. And if you want to dimension how thick that horizontal leg is, you dimension it in this side view where you can see the L. That's where that leg is true size and true shape. Do not dimension it in this side view because you don't know what it is. There's a line there, fine, but you can't see that it's an L-shaped leg until you go searching for another view over here. We'll come back and talk about this one some more next week.